A new breed of weapons, hypersonic missiles and laser weapons, are finally here. At first glance, hypersonic missiles are like every conventional missile out there, complete with warheads, guidance systems, and rocket engines that thrust them into the sky. But hypersonic missiles go a few steps further. One, like ICBMs or intercontinental ballistic missiles, and as their name suggests, they reach hypersonic speeds, hurling into their targets at over 5 times the speed of sound, or over Mach 5. Secondly, they fly at unexplored medium altitudes, much lower than ICBMs and yet much higher than current conventional missiles. Thirdly, and most importantly, they have very agile maneuverability, making their flight path as unpredictable as a Super Bowl game, and therefore much more difficult to intercept than any type of missile before them. Revolutionary to say the least, laser weapons are simply different and in a class of their own. They're not limited to the need for rocket engines or even warheads. They don't take out their targets with these kinetic tools, but instead intense beams of directed energy. This comes with a number of advantages over other types of weapons. These advantages include an unlimited magazine depth, since laser weapons don't have to fire anything kinetic. As long as they're connected to some power source, they keep firing. Then there's also the speed of light attack. Laser is a form of light and therefore travels at the speed of light. While the Mach 5+ speeds of hypersonic missiles does sound good, the laser's 180,000 mph top speed makes hypersonic missiles look slow. For these reasons and more, the US, China, Japan, India, South Korea, and Australia, some are allying, some competing fiercely, but all aim to build the most advanced hypersonic weapons and lasers they can. China's hypersonic game is no joke. Right now they're recognized as the leader in hypersonic systems, with the DF-17 hypersonic glide vehicle already in action. The world got its first glimpse of the DF-17 during a massive military parade in Beijing in late 2019. The DF-17 system is smart. It uses a traditional ballistic missile booster to launch its glide vehicle, which then re-enters the atmosphere to strike its target. And here's the kicker. These DF-17s are mounted on 5-axle wheeled transporter erector launchers, meaning they're road mobile, just like much of China's ballistic missile arsenal. This mobility could make it a real challenge for adversaries trying to take out these systems before launch. But China's not stopping there. Rumor has it they're working on an air-launched HGV-2. A video on Chinese social media briefly showed a PLA Air Force Shan H-6N bomber landing with what looked like a boost glide HGV, or maybe just a mock-up for testing. China's also diving into directed energy tech. State media has shown off handheld and vehicle-mounted lasers that can do some serious damage. One handheld laser weapon designed for crowd control can reportedly do much more: scorch skin, ignite clothing, take down small drones, or even blow up fuel tanks when cranked to full power. There's even a claim from a Chinese academic that the PLA used microwave weapons to disable Indian troops in a border standoff last year, though no independent sources have confirmed it yet. The US has multiple hypersonic programs, all aimed, individually or working together, at building entire arsenals of this unstoppable weapon. 2 of the most notable of these programs are of the US Air Force, and they include 1. AGM-183A Air-Launched Rapid Response Weapon. The AGM-183A Air-Launched Rapid Response Weapon, pronounced ARRW, was one of several hypersonic missile programs that the US government initiated after Russian and Chinese hypersonic missile programs were publicized in the mid-2010s. Developed by Lockheed Martin, ARRW is a hypersonic conventional missile designed to take out mobile and other time-sensitive targets up to 1,000 miles away and in amounts of time so little the targets cannot react. The missile consists of a large rocket booster with an unpowered, wedge-shaped boost glide warhead on top. To take out its targets, the warhead uses the booster to get to conventional speed and incredible heights. It then detaches from the booster and glides downward into the target at speeds up to Mach 20, or 20 times the speed of sound. It's already beyond theory, too. On May 14, 2022, the $15 to $18 million missile demonstrated separation from the B-52H Stratofortress bomber, Its booster burned for the expected duration, and then the warhead accelerated to hypersonic speeds. The ARRW looked set to become the Air Force's first operational hypersonic weapon. It was expected to start entering service by 2022, where it would be carried by the B-52 bomber fleet. However, in March 2023, after multiple development issues, the Air Force announced its intent to end the program. The results of the current tests with the weapon at a little-known place called Guam will likely contribute to the development of other hypersonic missiles, such as the Hypersonic Attack Cruise Missile. Number 2. Hypersonic Attack Cruise Missile. The Hypersonic Attack Cruise Missile, HACM for short, is the resulting scramjet-based hypersonic weapon from a joint project between the US and Australia. HACM doesn't require a rocket booster like the ARRW does. Instead, it has an air-breathing design that enables it to operate like a conventional missile and yet reach hypersonic speeds while maneuvering. To build the HACM, the U.S. Air Force awarded 3 contracts in June 2021 to Boeing, Lockheed Martin, and Raytheon Technologies for preliminary designs. 15 months later, in September 2022, the Air Force crowned the offering from Raytheon Technologies, earning the company, along with partner Northrop Grumman, a $985 million contract to develop the actual missile. The missile's exact specification is yet to be publicized, but it is expected to travel much faster than Mach 8. HACM is portable enough to be compatible with not just bombers, like in the case of ARRW, but also fighters. HACM is a more refined version of ARRW, but without ARRW, might not exist as it does today. Born out of science fiction, the rival in question is the laser weapon. The U.S. is investing roughly $1 billion a year on programs aimed at developing laser weapons and similar directed energy weapons. 2 of the most notable of these programs include: Number 1. IFPC HEL. The Indirect Fire Precision Capabilities High Energy Laser, or IFPC HEL for short, is a 300 kilowatt laser weapon designed to take out heavy threats such as cruise missiles. The result of a 3-year project to develop technologies that would protect fixed and semi-fixed sites, the IFPC HEL is a mobile complete system packed with its beam control, beam director, power and thermal management components. In 2022, Lockheed Martin supplied the Department of Defense with a 300 kilowatt laser that could be integrated into the IFPC HEL. It remains the most powerful laser that Lockheed Martin has ever produced. Number 2. DEM SHORAD. The Directed Energy Maneuver Short-Range Air Defense Laser Weapon, or DEM SHORAD for short, is a more everyday weapon that fires 60 kilowatt laser shots to take out UAVs and other similar-sized targets from 5 miles away. It could achieve this by blinding sensors, causing aerodynamic failure, disabling target engines, detonating fuel supply, or detonating an onboard explosive payload prematurely. An interesting feature of the DEM SHORAD is its level of intelligence. The weapon is, in the case of multiple targets, able to autonomously determine which should be destroyed first based on how much of a threat each target poses. DEM SHORAD was well developed in a record time of under 2 years. And once completed, the system will be mounted on the rugged Stryker infantry armored vehicle to traverse the battlefield with ease and grill some targets. India's Ministry of Defense laid out some ambitious goals in its 2018 Technology Perspective and Capability Roadmap. Over 200 new pieces of equipment were outlined for induction by the late 2020s, and one of the highlights? A tactical high-energy laser system for both the Army and Air Force. They're envisioning a laser weapon mounted on a high-mobility vehicle built to knock out everything from electronic warfare setups to radar antennas. And it's no small dream. They're aiming for a 20-kilometer range with target locking capabilities and even a potential role in anti-satellite missions from land or air. The estimated price to make this high-power laser vision a reality is $100 million. Then there's the BrahMos 2 hypersonic missile, fully homegrown and a real game-changer for India's maritime defense. Originally based on Russia's Zircon cruise missile, the BrahMos 2 is built for speed, though it's reportedly capped at Mach 6 for export control reasons, compared to Zircon's Mach 7+. Still, with a range of 500 to 1,000 kilometers and its role as a maneuverable anti-ship missile, the BrahMos 2 is set to give India a serious edge in the waters. Japan jumped into the hypersonic race in the late 2010s, and they've got big plans. They're working on two types of hypersonic systems: the Hypersonic Cruise Missile, HCM, and the Hypervelocity Gliding Projectile, or HVGP. The HCM is set to be a scramjet-powered missile, looking like your typical missile but packing way more speed and the range to match. The HVGP, though, has a different setup. It'll use a solid fuel rocket to launch a warhead up to high altitude, where it'll then glide toward its target, keeping up its speed using that altitude until impact. Japan's also getting strategic about its warheads. For maritime targets, they're designing an armor-piercing warhead made to punch right through an aircraft carrier deck. For land targets, they're planning a version with multiple explosively formed projectiles for hitting wide areas. To make all this happen, Japan's government has earmarked 240 billion yen, around $2 billion, in the latest defense budget, with Mitsubishi Heavy Industries on board to drive research on both the HCM and HVGP. Japan's definitely serious about stepping up in hypersonic tech. The Korean Peninsula is heating up the hypersonic arms race too. South Korea, a key U.S. ally, is charging forward with plans to develop its own hypersonic missiles as a counter to North Korea's significant ballistic missile stockpile. South Korean Defense Minister Jung Kyung-do announced plans to fast-track the development of long-range and hypersonic missiles, along with more powerful warheads to go with them. South Korea has already rolled out short-range ballistic missiles, but is now aiming for more advanced types that can hold critical North Korean targets, including their mobile missile launchers, at risk if conflict breaks out. For now, though, there's not much concrete information on how far along South Korea's hypersonic tech actually is. In 2020, Australia rolled out two major defense documents, committing 9.3 billion Australian dollars, or 7.1 billion US dollars, to ramp up its hypersonic weapons and directed energy capabilities. Australia's been digging into hypersonic tech for a while, mainly through the Hypersonic International Flight Research Experimentation, or HIFIRE program. This program pulls together talent from the government's Defense Science and Technology Group, the University of Queensland, the U.S. Air Force Research Lab, and big players like BAE Systems and Boeing. Their goal? A scramjet-powered precision strike missile that can hit Mach 5. If all goes as planned, it could be in service by the late 2020s or early 2030s. But Australia's not stopping at hypersonics. The Force Structure Plan calls out another game-changer: a directed energy weapon system that's set to be integrated into armored fighting vehicles, with enough power to take out targets as hefty as main battle tanks. And they're looking to use this tech for protecting naval vessels against cutting-edge threats too. Leading the charge in directed energy tech is Australian company Electro-Optic Systems, with over 35 years of laser expertise. They already provide space domain awareness services, tracking objects in space for Australia and allies. Now, they're also building a scalable directed energy counter-drone weapon for the Australian Defence Force, starting with a 26-kilowatt continuous wave laser. Australia's serious about staying ahead in the high-tech arms race. Hypersonic missiles and laser weapons are groundbreaking weapons in every way. They introduce to the battlefield capabilities that do not currently exist. With the budgets, manufacturers, and governments on board, the only piece left to complete these weapons is you giving this video a like and subscribing